Hi boys, we finished compound interest part 1 yesterday. The first part of the topic was about calculating compound interest, uh, amount, principal, rate, number of years, using rather not using the formula. A second part of the chapter uses a formula. So let's see how it works. For that, we'll need to remember a basic formula. How to calculate the formula is not a part of your syllabus. Otherwise, it's a very simple derivation which we can do maybe another time. So amount is equal to principal multiplied with 1 plus r upon 100, r being the rate and n is time. So n is time, r is rate of interest, a is amount, and p is principal. So this is one formula that you need to remember, like the way we remember our simple interest formula. Simple interest is equal to PRT upon 100. So let's solve a couple of questions. I am on question number 1. Uh, Yeah, there are two more formulas to this. As in when we come to those questions, I'll share those formulas with you. So right now, let's focus on this one. So find the amount and the compound interest on 12,000. So P is given equal to rupees 12,000 in 3 years. N is equal to 3 years, and the rate is given as 5% compounded annually. So let's look at this. So amount will be equal to principal, which is 12,000 times 1 plus 5 upon 100 raised to the power 3. So this is 5 into 20. So it will be 12,000 multiplied with 21 by 20 raised to the power 3. So this will be equal to 12,000 multiplied with 21 into 21 into 21 upon 20 into 20 into 20. 0 goes, 0 goes, 0 goes, and these three zeros go. 2 1 2 6 2 1 2 3. So that's 21 into 21 into 21 multiplied by 6. I have done this calculation already, and this amount is rupees 13,891.50. I repeat, if you're talking about money, then you need to write your answer with two decimal places. And how would I calculate the compound interest? Compound interest will be equal to amount minus principal, which is 13,891.50 minus 12,000. So it will be equal to rupees 1,891.50. And let's look at question number 2. Question 2. Now, before we do question 2, let's look at a different formula. Now, this was a case when the rate remains same for all years. Now, what happens if rate for first year is different and for rate for second year is different, rate for third year is different? Then we use another formula, which is A is equal to P times 1 plus R1 upon 100, 1 plus R2 upon 100, 1 plus R3 upon 100, and so on and so forth for the number of years that we need to calculate. Please notice that this formula and this formula is exactly the same. In this, if it was 2, if n is 2, this will be 1 plus r by 100 multiplied with 1 plus r by 100, right? And in this case, if it is 2, this is rate for first year, this is rate for second year. There's no difference. Just that in case the rate itself is different for different years, this is the formula that you'll use. So let's go. Calculate the amount if 15,000 is lent at compound interest. So P is given as 15,000 at for 2 years, rate being 8% and 10%. So R1 is 8%, R2 is 10%. We need to calculate the amount. So A will be equal to 15,000 1 plus 8 upon 100 multiplied with 1 plus 10 upon 100. So this will be 4 multiplied by 2, 4 multiplied by 25. This is 10 and this is 10. So this is 15,000 into 27 upon 25 multiplied with 11 upon 10. 0 goes, 0 goes. 25 1, 25 6 are 150, 150, and this is 60. So the amount will be 60 into 27 into 11, which will be equal to rupees 17820. So now let's look at question number 5. So right now, like if you notice, in this formula, there are 1, 2, 3, and 4 variables. Out of 4 variables, 3 were given. Here P and R were given, A had to be found. Similarly, P, R, year in any case was 1 year each was given, we had to calculate A. Now, something else will be given and we'll have to calculate either R or N. So let's look at the second type of question. On what sum of money will the compound interest for 2 years at 5% per annum be equal to uh, 768.75? Perfect. So on what sum? P is not given. Compound interest is given equal to rupees 768.75. N is given equal to 2 and R is given equal to 5%. Now, before we start, let's look at another formula. We know CI is equal to amount minus principal. So amount for this formula is P times 1 plus R upon 100 raised to the power N minus P. Anything common between these two elements? Yes, P is common. So P, if I take common, what remains is 1 plus R upon 100 raised to the power N minus 1. Why 1? Because I have taken P common. So this is what we learned in factorization. So this question we'll need to use this formula. So let's see. In this question, it says 768, which is my uh, compound interest, is equal to P, which we don't know, times 1 plus R, which is 5 upon 100 raised to the power N is given equal to 2 minus 1. So 768.75 is equal to 51520. So equal to P times 21 upon 20 square minus 1. 768.75 is equal to P times 21 square is 441. I will rewrite it. P times 21 square is 441, 20 square is 400 minus 1. So 768.75 is equal to P times 441 minus 400 upon 400, which means I will start writing from here. Pardon my, I have lesser space. So 768.75 is equal to 441 minus 41 is 41p upon 400, which means p will be equal to 768.75 multiplied by 400 upon 41. I have done this calculation already, and this is equal to rupees 7,500. Thank you.